This video is about extracting metals. You don't find big lumps of many metals in the ground. The metal atoms tend to be joined to other atoms in compounds. We need to separate these other atoms from the metals in order to be able to use it. Metal ores are rocks that contain varying amounts of minerals from which metals can be extracted. Often, ores are oxides. Okay, so iron ore is made of iron oxide. Okay. For some metals, you need an awful lot of ore just to be able to get a small percentage of the mineral out. Copper mining, you need a huge amount of copper or even to get just a tiny amount of copper. Copper ores typically contain only 1%. There are two ways that we can extract metals, that is the metal that we actually want, from their ores or from their minerals. The first is by a process called reduction with carbon. And that's what this video is going to talk about in more detail. The second is electrolysis. So these are the two ways that we can extract the metals from minerals that have them found in the ground. Which method you choose, reduction with carbon or electrolysis, depends on how reactive the metal is compared to carbon. Metals that are higher up the reactivity series, which is shown in this diagram on the left, metals that are higher up the reactivity series than carbon, i.e. are more reactive, we have to extract using electrolysis. However, metals that are lower down the reactivity series than carbon, we can extract by reducing them with carbon. We can react them with carbon. So, any metal that is less reactive than carbon, that is lower down the reactivity series, we can extract from an ore by reacting it with carbon. This works because the carbon that is more reactive literally steals the oxide group from the iron that is less reactive. So iron oxide and carbon react together to make iron and carbon dioxide. Okay, iron and carbon dioxide. Any metals that are below carbon in the reactivity series will react in exactly the same way. Okay, so for example, lead. Lead oxide and carbon will react to form lead and carbon dioxide. This is how we can extract the product that we actually want, the lead, from the lead oxide. The metal oxide, in this case the lead oxide, is losing oxygen. It's losing the oxide group. We call this reduction. Okay, losing oxygen equals reduction. The carbon is gaining oxygen to become carbon dioxide, and we call this oxidation. Okay, gaining oxygen is called oxidation. When reduction, losing oxygen, and oxidation, gaining oxygen, happen at the same time, we call this a redox reaction, okay, i.e. reduction and oxidation at the same time. The lead oxide loses oxygen, it's reduced to form the lead, which is what we're trying to extract. The carbon gains oxygen to become carbon dioxide and is oxidized. Together, it's a redox reaction. Remember, in exactly the same way, any of the metals that are below carbon, they are less reactive than carbon, can be extracted from their ores in this way, through reduction with carbon.